Assalamu alaikum. This is the fourth class of vectors. Today we're going to learn how to find out the perpendicular distance from a point to a line. Okay, just graphically if I have to explain, if this is a point and this is the line, if I want to find out the perpendicular distance between the two, okay, what is the method which I'm going to use, because perpendicular distance is the shortest distance possible from a point to a line. So if you want to find it out, we have done it in coordinate geometry in ADMATS and even in P1, how to find out the perpendicular distance between a point and a line, but here we are using vectors to do the same. Okay, let's start with this. Shortest distance from the point P to the line with equation this. Okay, okay, for instance, this is line and this is the point P whose coordinates are given to us 11, -5 and -3, and we have to find out the perpendicular distance between this point and this line. That means you have to find out this distance. Okay, since we have the vector equation of the line, we can call this point as n, and we know for this particular n the coordinate can be written in the form 1 minus 3 lambda, 5 plus lambda, and 0 plus 4 lambda. For every single point on this line, lambda will be different, but for this point, if we take lambda as it is as an unknown constant, or you can even replace lambda with any other variable like t or anything. I'm taking it to be lambda only. So if I call this point as this, I know that the perpendicular distance can be if the two lines are perpendicular to each other, the product of the dot product the dot product of the two vectors is going to be, the dot product of the direction vector is going to be 0. So we already have the direction vector of this line, okay, which is -3, 1 and 4. We need to find out the direction vector of this line. That means we have to find out Pn or Np, whatever. Okay, so if I have to find out Np, I'm going to write On minus Op. On is 1 minus 3 lambda, 5 plus lambda, and 0 plus 4 lambda, minus Op, which is 11, -5 and -3. Let's find out Np first. So it's going to be 1 minus 3 lambda minus 11. That means it's going to be -10 minus 3 lambda. Okay, 5 plus lambda plus 5 is going to be 10 plus lambda. 0 plus 4 lambda minus 3, which is going to be -3 plus 4 lambda. Okay, this is Np. Now I have to find out since I already have the direction vector of this, which is here, I can find out the dot product. I know that the dot product of the two vectors will be 0 because the two lines are perpendicular to each other. Okay, so I will find out the dot product of -3, 1, 4 and -10 minus 3 lambda, 10 plus lambda, and -3 plus 4 lambda. Okay, let's find it out. -3 times -10 minus 3 lambda plus 1 times 10 plus lambda plus 4 times -3 plus 4 lambda. The dot product will be 0 if the lines are perpendicular to each other. Okay, let's solve this. 30 minus plus 9 lambda okay, plus 10 plus lambda minus 12 plus 16 lambda equals to 0. So 9 plus 16 is 25. 25 plus 1 is 26 lambda equals to 40 minus 12 is 26. So it goes onto the other side and becomes -26. Okay, so lambda equals to -1. Once I have the value of lambda, I can plug it in here and get the value of On. Okay, I can write in the beginning only, let On equals to 1 minus 3 lambda, 5 plus lambda, and 0 plus 4 lambda. Okay, now I have On with me, which is 1 minus 3 into -1. I'm plugging in lambda in place of the value of lambda in place of lambda. Okay, 5 plus -1 and 0 plus 4 times -1. So this has become 1 plus 3, which is a 4. 5 minus 1 is also 4, and minus 4 here. So I already have ON with me. Since I have OP and ON, I can apply the formula of distance. OP is 11 minus 5 and minus 3. And ON is 4, 4, negative 4. Write it in the vector form. 11 minus 5 and minus 3. Okay, let's find out the distance between the two. So the formula for distance, x1 minus x2 the whole square plus y1 x1 minus x2 the whole square plus y1 minus y2 the whole square plus z1 minus z2 the whole square. Okay, let's do it. 11 minus 4 the whole square plus minus 5 minus 4 the whole square plus negative 3 plus 4 the whole square. Okay, 11 minus 4 is 7 square plus minus 9 square plus 1 square. 49 plus 81 plus 1. 49 plus 82. Square root of 131 is going to be the distance between the two, which is 11.4 units. This is the answer to this question. Let's do another one. Find the distance of the point to the line joining the points A and B. Okay, so assumingly C is the point, and you have to find out the distance between C, and whenever they talk about the distance, that means they want the perpendicular distance, otherwise they will mention. Okay, so A is the point minus 4, 2 and negative 3, and B is the point minus 2, 0 and 1, and C is the point 0, 6 and 1. Okay, what we have to do is we have to find out this value. Okay, the direction vector of firstly let's form the vector equation of this line. So the vector equation of the line is firstly I'm going to find out AB, which is OB minus OA. Okay, minus 2, 0 and 1 minus 4, 2 and minus 3, which is coming out to be a minus 6, negative 2, and 1 plus 3 is a 4. Oh, I'm just erasing this. This was a minus 4, 2 and a negative 3. Okay. Minus 2 plus 4 is a 2. Minus 2 and 1 plus 3 is a 4. Okay, I already have AB with me. So the vector equation would be, I have to write it like this. OA, which is minus 4 to negative 3. Plus I can use any other variable. I'm using mu here. Times AB, which is 2, negative 2 and 4. This is the vector equation of the line AB. Now, I'm calling this point as N, and obviously for this point, if I take this point, can be for a certain value of mu. If you get the value of mu of this point, you can just plug it in here and get the coordinate 2 minus 2 mu and minus 3 plus 4 mu. Okay, let ON equals to minus 4 plus 2 mu, 2 minus 2 mu, minus 3 plus 4 mu. Okay, now what I want is the I know if the two lines are perpendicular, the scalar product or the dot product is going to be 0. For the dot product, I need the direction vector of this line and the direction vector of this line. For I have the direction vector of this line here, which is this direction vector of the line AB. Okay, and I want the direction vector of this line, which is NC. Okay, so I can easily find out NC, which is going to be minus 4 plus 2 mu, 2 minus 2 mu, minus 3 plus 4 mu, minus 0, 6 and 1. Okay, so I'm getting a minus 4 plus 2 mu here, minus 4 minus 2 mu, minus 4 plus 4 mu. Okay, so if I have NC with me, now I can get the dot product, finding scalar product of NC and direction vector of AB. Okay, so I want to find out the dot product. So 2, -2 and 4 multiplied by a -4 plus 2 mu, -4 minus 2 mu, and -4 plus 4 mu. Let's do that. Okay, 2 into -4 plus -2 into -4 -2 mu plus 4 into -4 plus 4 mu should be equals to 0. Get the value of mu first. So it's -2 okay, hold on, I just forgot to write this completely. Should be 2 into -4 plus 2 mu. Okay, so it's going to be a -8 plus 4 mu plus 8 plus 4 mu minus 16 plus 16 mu equals to 0. Okay, -8 plus 8 will cancel out. 16 plus 4 is 20 plus 4 is 24 mu, and equals to 16. Mu equals to 16 upon 24, which is a 2 upon 3. Okay, if you plug in 2 upon 3 into this point, you will get the coordinates of n. Okay, ON is going to be -4 plus 2 mu okay, -4 plus 2 mu 2 minus 2 mu -3 plus 4 mu. Okay, let's plug in the value. -4 plus 2 times 2 upon 3, 2 minus 2 times 2 upon 3, -3 plus 4 times 2 upon 3. Okay, I'm getting a -4 plus 4 upon 3, 2 minus 4 upon 3, -3 plus 8 upon 3. Okay. Okay, which is a -10 upon 3, 2 upon 3, and -1 upon 3. Okay, so this is ON now. I have OC and ON both. I can apply the formula of distance. OC is given to me as 0, 6 and 0. Okay, let's apply the formula of distance. 0 plus 10 upon 3 the whole square plus 6 minus 2 upon 3 the whole square plus 0 minus -1 upon 3, that means 0 plus 1 upon 3 the whole square. This is going to give us 100 upon 9 plus 6 minus 2 upon 3 is 16 upon 3. So 16 square is 256 upon 9 plus 1 upon 9. Okay, so 100 plus 256 plus 1. 357 upon 9 the square root. The answer is 6.29 units is the distance between them. Okay, just to give you a quick review of how do we go about finding out the perpendicular distance between a point and a line where the vector equation is given. If the vector equation is not given, you have to first find out the vector equation. Once you get the vector equation, you can replace lambda with other variable, or you can let it be lambda and mark this point and let the coordinate of this point be 1 minus lambda, 3 lambda, 5 plus lambda, and 0 plus 4 lambda. Okay, after this we have to find out the mm, um, because we know that the two lines are perpendicular to each other, so the dot product is going to be 0. For the dot product we need the direction vector of this line and the direction vector of this line. The direction vector of this line is available because the vector equation is available. You can get the direction vector of this line by if it is Pn, you can take it to be On minus Op, or you can take it to be NP, which is OP minus ON. Subtract them and get the direction vector, and then multiply the find out the cross product or the scalar product of the direction vector and make it equal to 0 because the lines are perpendicular. Get the value of lambda. Once you get the value of lambda, you plug it in to get this point. Once you get the 2 points, apply the formula of distance, x1 minus x2 to the whole square plus y1 minus y2 to the whole square plus z1 minus z2 to the whole square to get the distance between the two. Thanks a lot for watching the video.